Okay, and I just noticed that at one point I inadvertently referred to that in inches. I should have said feet. I hope that didn't throw you off. Okay, so it's all in feet, and I wrote this down for your convenience, recopied it onto this frame. And our step 2 then is to solve an equation to find x. Well, this is a perimeter problem, specifically perimeter of a rectangle. So the formula for the perimeter of a rectangle is 2 times the length plus 2 times the width is equal to the perimeter. But we know that the length is 7x and the width is 5x, so we can substitute those values in there. And then 2 times 7x is 14x, 2 times 5x is 10x, and then continuing to simplify, we get 24x is equal to 48. Divide both sides by 24, and we get that x equals 2. So, aha, we found out that x in this case equals 2. Our next step then will be to evaluate the expressions that we wrote in step 1 for the actual length and width. Okay, so the length is 7x, but we now know that x is 2, so the answer is the length is 14 feet. And similarly with the width, we know that the width is 5x, but we now know that it's x is 2, so it's 5 times 2, or 10 feet. So we have 14 feet and 10 feet would be the length and width of a rectangle. That's in a ratio of 7 to 5. The length to the width is in a ratio of 7 to 5, and it adds up to a perimeter of 48 feet. Okay? And then moving right along, we have this problem. A triangle's angle measures are in the extended ratio of 1 to 3 to 5. Find the measures of the angles. So again, step 1 would be to write the expressions for the angles. So let's explore that a little bit. We have these angles, and they're in this ratio. Well, obviously, that does not mean that this is 1 degree, and this is 3 degrees, and this is 5 degrees. I mean, that's obviously not what it's saying to you, right? For one, the total angular measure inside of a triangle is 180 degrees, so that certainly can't be 1 plus 3 plus 5, right? That would only be 9 degrees, impossible. But it's in that ratio, okay? And so again, using that same type of argument that we presented in problem 3, it must be multiplied by the same number to keep it in the same ratios. What is that number? We don't know. So we'll have to refer to it at this point as x. So we have that 1 degree is going to be 1 times some number, the other degree is going to be 3 times some number, and then the last degree measure is going to be 5 times some number. And so if we add them up, all the degree measures inside of a triangle, we add them up and we get the total angular measurement inside of a triangle, which, as you know, is 180 degrees. So that's our step 2, basically coming up with an equation. And so now we have, simplifying, we have 9x is equal to 180, and then we would divide both sides by 9 and get x equals 20. So now we know that x equals 20, and we can go back and evaluate the expressions that we created for each of the individual angles. Back in step 1, we can go back and plug in x equals 20. Well, the first one, remember, was 1 times x, so that's just x, so x equals 20 degrees. So one of our angular measurements is 20 degrees. The next one is 3x, so that's 3 times 20 degrees, or 60 degrees. And then the last one is 5x, or 5 times 20, which is 100 degrees. So we have our 3 angles. They are in a ratio of 1 to 3 to 5, and if you add them up, you would get 180 degrees. Okay? All right, moving right along now, we have another, the other kind of concept or the other topic that we're covering is proportions. And so if we have a problem like this, 2 over x is equal to 5 over 8. The way you solve this is by cross multiplying, and then we would get 5 times x is equal to 2 times 8, or 16. 5x is equal to 16. This should all be ringing a bell. We've been doing this in the past. I'm just kind of reviewing it, like I said, because it will be used in this chapter on similarity. You divide both sides by 5, and you get x is equal to 16/5. Okay? And you can just keep that like that. That is written in lowest terms. So the answer is 16/5. Okay? Moving right along to the next problem. We have 1 over x minus 3 is equal to 4 over 3x. Same methodology for tackling the problem. We cross multiply, and then we would get 3x is equal to 4 times x minus 3. And then 3x then will be equal to, give me a moment here, I would take this 4 and use the distributive property on the x minus 3 and get that 3x is equal to 4x minus 12. Take away 4x from both sides and get negative x is equal to negative 12. You can divide both sides by negative 1 and get x is equal to 12. Okay, and here's that third concept I was talking to you about, one that you might not have seen in the past. I definitely have not introduced it to you in the past before. So moving right along, it's the geometric mean. And the geometric mean of two positive numbers, a and b, is the positive number x that satisfies the proportion a over x is equal to x over b, such that, or therefore, or so, x squared equals a times b. And x then is the square root of a times b. And this is the wording that was given to you in the book. That's why I typed this up, I had you write it down. But really the important part is right there, okay? That the geometric mean is equal to the square root of a times b. So basically, the geometric mean of two numbers is you take those two numbers and you multiply them, that's what a times b is, and then you take the square root, okay? So that's basically what it is right there. Geometric mean, multiply the two numbers, take the square root. So let's try that. Find the geometric mean of two numbers, and let's say those two numbers are 12 and 27. So remember what I just said. Step one is to multiply the two numbers. So we have 12 times 27 is 324, and then step two is to take the square root of that number, the square root of the product. So the square root of 324 is 18. So the geometric mean of 12 and 27 is 18. Again, the geometric mean of 12 and 27 is 18. And all I did to find that out is multiply the two numbers and then take the square root. So just remember that. Geometric mean, multiply, take the square root. So let's try that one more time. Let's say it's the two numbers are 10 and 2. So we have that x is equal to the square root of the two numbers, right? That's basically what it's saying, right? I'm just kind of using the formulas this time. But it's the same thing. You multiply the two numbers and then you take the square root. So we have 10 times 2, which is 20. So we have the square root of 20. And you might think, okay, well, I'm done. And we are kind of done with the geometry part. But remember that these radicals should always be expressed in lowest terms. And to express these radicals in lowest terms, you have to find the greatest perfect square that goes into 20. The largest perfect square that goes into 20. And that number would be 4. 4 is the largest number I can think of that goes into 20 that is also a perfect square. And a perfect square means a whole number times itself equals that number. So like 4 is 2 times 2. So that means 4 is a perfect square. Okay, so again, 4 is the largest perfect square that can go into 20. And the reason why I do that is because I'm going to break it up, right? If we have the square root of 4 times 5, that's equal to the square root of 4 times the square root of 5. And the reason why I chose 4 is because it's a perfect square and the largest perfect square. So when I take the square root, I'm going to get 2. The square root of 4 is exactly 2, right? It's a perfect square. And the square root of 5 cannot be simplified, so it's root 5. So the answer then would be 2 root 5. So the geometric mean of 10 and 2 is 2 root 5. Okay? So that's the end of the lecture. If you have any questions or concerns, please feel free to contact me at your convenience, and it would be my pleasure to help you. Okay? Bye-bye.